Fourier transform of the derivative. So we have to prove that Fourier of f nx means n time derivative will be equal to minus 1 minus iota s the power n fs. This is basically n means if it is 1, then derivative only once only, and if it twice derivative means it will be 2 here, right? Okay, we know the formula f of Fourier of this fx will be 1 by 2 pi n root minus infinity to plus infinity, and fx e the power iota sx dx. This will be equal to fs, and the condition is that fx will tend to 0 when x tend to plus infinity or minus infinity. So f of f dash x by applying this formula. So fx I will replace with f dash x. So accordingly it will be 1 by 2 pi minus under root minus infinity to plus infinity. Fx will become f dash x e the power iota sx ds. So now you can this you can apply uv formula. This as u, this as v, right? So f Fourier of f dash x will be 1 by 2 by under root. So uv formula I apply. So this e the power minus iota x as such, and then the integral of this part f dash x will be fx minus infinity to plus infinity, then minus infinity to plus infinity. That's e the power iota sx derivative of this one. Then that will be is iota s will be there, right? And integration of this part, it will basically the simply fx will be there like that. So fx tend to 0 as x tend to f minus to plus infinity, right? Sorry, that will be equal to, then function will be equal to 0. Means you take the limit from minus infinity to plus infinity. So now f of f dash x will be equal to minus 1 by 2 pi under root, as in the previous slide, minus infinity plus infinity e the power iota sx iota s fx ds as such. So first part was 0. So now f of this one is equal to minus iota s, you can take outside, minus hardly there, minus iota s 1 by 2 pi under root, left is e the power iota sx fx dx. So Fourier of f dash x will be equal to what? It will be minus iota. This part will be fs. So iota s fs. Now second derivative. Derivative means the Fourier of f double dash x. So what is that? 1 by 2 pi under root, same formula as in the previous slide. So minus infinity to plus infinity, and fx will be replaced by the f double dash x. So in that way, so e the power iota xx and f dash x you can suppose as e, this has v. You can apply the formula, uv formula. So 1 by 2 by under root e the power iota as such, then the integration of this part, this f double dash x. So minus this differentiation of this part, then integration of this part, then integral, final integral is here also. That you know the formula for uv. In the integration, that same formula I am applying. So if fx tend to 0, then fx will be tend to 0, not if when x tend to plus infinity to plus minus infinity. So similarly, f dash x will also tend to 0 when this x tend to plus minus infinity. So first part above will be 0 because this part is 0. So only left is this part only. So f double dash x will be equal to this part will be 0 minus this part, like that. Now f of double dash x will be equal to minus iota s you can take out. 2 pi, this already there. If you write here also. So what is left is f dash x dx e the power iota sx. And f of this one is equal to what? Minus iota s, say 1 by 2 pi, this formula. That is what? That is Fourier of this one, or f dash x, that the formula for this Fourier of the function, this function. So, or you can say iota s, this whole part you can write as fs also, as it in the question 1. So f of Fourier of f double dash x will be minus iota fs, means minus iota square, like that. So double dash is there, it will be square. If it is three dashes with 3 time derivative, it will be minus iota as the power 3, like that. So on. So we can prove that f the power fns x will be iota minus iota the s the power n, right, fs. So that was required also. That is the derivative. Thank you.